Here we are going to arrange the remaining 5 letters in 5 factorial way, that's equal to 120. All the 3 vowels as 1 unit, then 1 unit plus the remaining 5 consonants, total 6 can be arranged in 6 ways. In the word hexagon there are 3 vowels and 4 consonants. Right, all the 3 vowels can be arranged in even places. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. So in this session today I am going to discuss the problems based on permutations. In the previous class we have discussed regarding formation of numbers depending upon the even number, odd numbers, and when the repetition occurs and when the repetition do not occur. So formation of the number depending upon the condition, if the repetitions occurs, if there is no repetitions, those problems which I have studied in the previous class. Now in this session today I am going to discuss regarding various types of permutations like word building, that is letters not repeated, words building letters with repeated, that is building of an words where the repetition is allowed and the repetition is not allowed. So using the repetitions and without using the repetitions, we are going to build the words from the given letters. Those type of problems which we are going to study in this session. That is very important for the point of examination. You might have been studied regarding arrangement of elements like mathematics, Missouri, Mississippi, engineering, like that. Okay, now let us move on to the first problem. Word building, letters not repeated. If there is no repetition, if the repetitions are not allowed, then how to form the permutation? So when the letters is no restriction, if there is no repetition, no restriction, then let us take an example. Find the number of words that can be formed using the letters of the word monkey, M-O-N-K-E-Y. So find the number of words that can be formed using all the letters of the word M-O-N-K-Y. So this contains 1, 2, 3, 4, 5, 6 letters are there. So this contains 6 letters. Using this, what is to form the number of words that can be formed using all the letters, all the 6 letters of the word monkey, right? Since here 6 letters are there, all the 6 letters can be arranged in 6 ways. That's all. So therefore the required permutation is equal to the required permutation. The 6 letters can be arranged in 6 ways. That is 6 ways. That is nothing but 6p6 is nothing but 6 factorial. 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. That is nothing but 720 ways. So the required permutation is 720 ways. That's it. So here 6 letters can be arranged in all the 6 letters in 6p6 ways. That is nothing but 6p6 is equal to 6 factorial. 6 factorial is equal to 6 into 5 into 4 into 3 into 2 into 1. That's equal to 720. That's it. Very simple for 2 marks. Now let us move on to the next problem. Case 2. When the words begin or end with the particular letter. Suppose if any word begins with particular letters or ends with particular letters, those type of problems can be solved. Now here, when the words begin or end with particular letters, now let us take an example for that. Find the number of words that can be formed using all the letters of the word rainbow. Right, see here. Find the number of words that can be formed by using all the letters of the word rainbow. How many of these begin with R and end with W? So how many of them will begin with R and ends with W? Then how many of them end with bow? So how many of them ends with bow? So W, O and B. Next, how many of them begin with R, O, W? R, O, W. That is R, O and W. This is what we are going to find. So let us start with, now the word rainbow has how many letters? The word rainbow has 1, 2, 3, 4, 5, 6, 7 letters. So the word rainbow has 7 letters. So total number of words are 7. So therefore 7 factorial is equal to 5040. Right. So 7 factorial. Write down 7 factorial. The number of arrangement of 7 letters is 7p7. That is nothing but 7 factorial. So here 7p7, that's equal to 7 factorial 5040. First, now let us come to the first condition. Oh, yes, here begin with R and end with W. How many of them begin with R and ends with W? So here there is one R and one W. So that means only 5 letters have to be arranged. 5 letters are to be arranged because it will starts with R and ends with W. So the remaining letters are A, I, N, B, O. So that is 5 letters. Only 5 letters have to be arranged. So therefore the total number of words will be 5 factorial. 5 factorial is nothing but 120. Right. So here we are going to arrange the remaining 5 letters in 5 factorial way, that's equal to 120. Now move on to the second condition. What is the condition? Words ending with BOW. BOW, right. Words which ends with BOW. So here the first case is word starts with R and ends with W. So the remaining 5, that is, can be arranged in 5 factorial. Second word, words ending with BOW. So here words ends with BOW. BOW. And its first letter is R. Right. So words ending with BOW. So how many letters are there? So remaining 4 letters. That is, this is gone, RAIN. So remaining 4 letters have to be arranged. So therefore the total number of arrangement is 4 factorial. That's equal to 24 ways. Now move on to the third one. What is the third condition? Began with ROW. So begins with ROW. So the words begins with ROW and the remaining. So the remaining 4 letters have to be arranged. The words began with ROW. The 4 letters have to be arranged in 4 factorial ways. That's equal to 24 ways. That's it. This is how we are going to solve. Very important for 3 marks. See here, how many of them? The word rainbow has 7 letters. Therefore, the total number of arrangement is equal to 7 factorials. That is 5040. Only 5 letters can be arranged. That is, if it begins with R, ends with W, means 5 letters can be arranged in 5 factorial ways. That is 120. Suppose words ending with ROW, that is BOW. If the words ends with BOW, the remaining 4, that is the 4 letters have to be arranged in 4 factorial. That is nothing but 24 ways. And the letter starts with ROW. The 4 letters can be arranged in same 4 factorial ways. That is equal to 24 ways. So now this is how we are going to arrange the words of the letter rainbow. Now move on to the next problem. Case 3. What is case 3? When few letters or vowels or consonants occurs together. Few letters like vowels, consonants occur together. If they vowels and consonant or few letters will occurs together, then how to solve those type of problems? Let us take an example. Consider an example for laughter. So in how many ways can the letters of the word laughter be arranged so that all vowels occurs together? Now first find out how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8 letters are there. In these 8 letters, how many vowels are there? Vowels. So vowels are how many? A, E, I, O, U. A, E, I, O, U. U is here. So 3 vowels are there. A, E, I is not there. A, E, I, O, U. O is also not there. U is there. Only 3 vowels are there. So in how many ways can the letters of the word laughter be arranged so that all the vowels occur together? All these vowels will occur together. Okay. Now there are 3 vowels and 5 consonants are there. How many vowels are there? 3. Remaining 1, 2, 3, 4, 5 consonants. 8 minus 3, that's equal to 5 consonants. So there are 3 vowels and 5 consonants. Consider these 3 vowels as 1 unit. All the 3 vowels as 1 unit. Then 1 unit plus the remaining 5 consonants, total 6 can be arranged in 6 ways, 6 factorial ways. So all the 1 unit of vowels and the remaining 5 consonants can be arranged in 6 factorial ways. 6 factorial ways. Okay. Yes, the 1 unit of vowels plus 5 consonants, all totally 6 can be arranged in 6 ways. The remaining, also the 3 vowels can be arranged in 3 factorial ways. The number of ways is equal to, therefore the total number of arrangement is equal to, multiply this, 6 factorial into 3 factorial. So just if you multiply 6 factorial into 3 factorial, what is 6 factorial and what is 3 factorial? Now what is 6 factorial? 6 factorial is nothing but 720 into 3 factorial is 3 into 2 is 6. So 720 into 6 ways. What is this equal to? So this is equal to 4320 ways. That's it. See, a very simple problem. There are 8 letters in which there are 3 vowels and the remaining 5 are the consonants. There are 3 vowels and 5 consonants. Consider all these vowels as one unit. So therefore, 1 unit of vowels plus remaining 5 consonants is equal to 6 total. Total number of arrangement is equal to 6. So since the 3 vowels can also be arranged in 3 ways, 3 factorial ways, therefore the required arrangement is equal to, just multiply these two, 6 factorial into 3 factorial, that is nothing but 720 into 6 is equal to 4320 ways. Hope you followed. Now move on to the next problem, that is case number 4. In case when vowels, consonants occupy odd or even places. Suppose if it occupies, the vowels and the consonants will occupy the odd places or even places. Now let's take an example for that. So in how many ways can the letters of the word hexagon be arranged so that the vowels are always in even places? So vowels are in which place? Even places. So the words of the letters of the word hexagon, how many letters are there? 1, 2, 3, 4, 5, 6, 7. There are 7 letters. 7 letters, right? So using these 7 letters, we have to arrange that vowels are always in even places, right? Now just identify how many vowels and how many consonants are there here. So here how many vowels are there? So A, E, I is not there, E, I, O, U. Yes, only 3 vowels are there. Consonants, 1, 2, 3, 4 consonants. 4 consonants. That's it. So if you multiply these two, that will give the answer. That's it. So here in the word hexagon, there are 3 vowels and 4 consonants. Right. All the 3 vowels can be arranged in even places. So the 3 vowels can be arranged in even places by 3 ways. All the 3 vowels can be arranged in even places by 3 ways. And the remaining 4 consonants can be arranged in 4 ways. The 4 consonants. So therefore the total requirement is equal to 3 factorial into 4 factorial. 3 factorial is 6, 4 factorial is 6 4s are 24. So 24 into 6. That's it. This will give the answer. Okay. Right. See here, the 3 vowels can be placed in even places by 3 ways and the remaining 4 consonants can be placed in 4 ways. So therefore the required permutation is 3 factorial into 4 factorial, that is 6 into 24, that's equal to 144 ways. That's it. This is the total requirement. That's it. Hope you followed. Now let's move on to the case number 8. Word building, that is letters repeated. If the letters are repeated, this is also a very important problem for 3 marks. Now if there are n things taken all at a time where x things are alike of one kind, so x things are of same kind and y things are of alike of another kind and z things are alike of other kind and so on. So if there are n things in which x, y, z are 3 types, they are of same type, x, y and z. So therefore the number of permutations is equal to n factorial divided by x factorial into y factorial into z factorial. So that is, if n things taken all at a time where x, y, z are different kinds, then the total permutation is equal to n factorial divided by x factorial into y factorial into z factorial. Now based on this, let us move on to a problem. Now let us take a problem based on this. Now find the number of permutations of the letters of the word engineering. How many of these? So first find out the number of permutations of the word engineering. Letter says letters of the word engineering. How many of these begin with E and end with E? How many all the 3 E's together? Third one, begin with G-I-N and end with G-R-I-N. All vowels are not together. no two vowels are together. This is an important. Now, let us find how many letters are there in the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words are there. 11 letters in the word engineering. Now, just begin with E and end with E, first case. Now, just find out how many letters. 7 letters are there. So, same kind. So, let us take how many E's are there. How many E's? Here, 1, 2, 3. 3 E's are there. N, how many N? N. How many N's are there? 1, 2 and 3. 3 N's are there. Then G, how many G are there? 1 and 2. So G's, how many G's? There are 2 G's. And the remaining I, how many I's are there? I's are 2. That is 1 and 2. So the remaining letters are 1, 1, 1. So no, just only one letter is left, that is R. R is 1. So totally 3 plus 4 plus 6 plus 1. Yes, 4 plus 6, 10 plus 1, 11 letters. So now first find out the total permutation with these letters. So therefore, first the total permutation is equal to 11 factorial divided by 3 factorial into 3 factorial into 2 factorial into 2 factorial into 1. So 2, 3 factorial and 2 factorial. So the total permutation is 11 factorial divided by 3 factorial into 3 factorial into 2 factorial divided into 2 factorial. Now let us move on to the first one. Begin with end and begins with E. So the letter begin with E and also ends with E. Right? Okay. Just find out the number of permutation which begins with E and ends with E. Therefore, the total permutation is equal to how many letters are there? So out of this 11, 2 is left. 11 minus 2, that is 11 minus 2 is 9 factorial in the numerator, and in the denominator how many letters are there? So here there are 3 E's. So remaining, what are the remaining? 3 N's, 2 G's and 2 I's with the letters starting with E and ending with V. With this we are going to write the required permutation as, so 3 N's, 2 G's, 2 S's and 2 I's. So the required permutation is 9 factorial divided by 3 factorial into 3 factorial into 3 factorial, where the word begins with E and ends with the E. So that is, here out of 11, 2 letters begins with E and ends with E, that is the 2 letters, that is E and A, and out of this remaining 9 factorial divided by 3 factorial into 2 factorial into 2 factorial will give the required permutation. Now move on to the second case. Have all 3 E's together. Now all the 3 E's together, write down. All the 3 E's together means all the 3 E. E, E and E. If all the 3 E's together, then the total permutation is equal to same 9 factorial divided by 1 3 is gone, remaining 3 factorial into 2 factorial into 2 factorial. So if all the 3 E's are together, consider that as one unit, then 9 factorial divided by 3 factorial into 2 factorial into 2 factorial. That's it. Okay. Now next one. Begin with G-I-N and ends with G-R-I-N. Begin with G-I-N. So here this will begins with G-I-N and ends with G-R-I-N. G-R-I and N. This is the given condition. So it will begin with G-I-N and ends with the G-R-I-N. Right. So begins with G-I-N and ends with G-R-I-N. Now here let us consider this as one unit and this as one unit. How many letters are remaining then? So 7, 4 plus 3, 7. So remaining 4 letters. 4 letters are left. In these 4 letters, what is left over is, there are 3 E's. So number of E's are 3. 3 E's are there. So therefore the required permutation is equal to 4 factorial divided by 3 factorial. That's all. 4 factorial divided by 3 factorial will give the value of begin with GIN and end with GRIN. Now move on to the next one. All vowels are not together. All vowels are not together. Just find out how many vowels are there, and to find all the vowels are not together, just find out number of permutation with all the letters minus the number of permutations with the vowels. So then if you subtract this, you will get all the permutations of the letters which are not together with the vowels. Now just find out here how many vowels are there. Vowels E, 3 E's are there. E, I, then that's it. A, E, I, A is not there. E, I, O is not there. U is also not there. A, E, I, O, U is also not there, right? So there are only 2 vowels, that is 3 E's and 2 I's. Therefore, the permutation with the vowels is, therefore, the permutation with vowels is equal to 5 factorial divided by 3 factorial into 2 factorial, right? Now, if you consider the vowels as 1 unit, then the permutation will be 7 factorial divided by 3 factorial into 2 factorial. Now, just write down the total permutation with all the vowels. So, the total permutation with all the vowels is equal to, multiply these two. 5 factorial into 3 factorial into 2 factorial into 7 factorial into 3 factorial into 2 factorial. Now, subtract these two. That's it. Now, therefore, the required permutation of all the vowels not together, all the vowels not together is equal to this first one, 11 factorial divided by 3 factorial into 3 factorial into 2 factorial into 2 factorial minus this quantity, minus 5 factorial divided by 3 factorial into 2 factorial into 7 factorial divided by 3 factorial into 2 factorial. This will give the total answer. Just subtract this from the total. This will give the answer. Now the last condition, no 2 vowels are together. Now here no 2 vowels are together means first just arrange the 6 consonants. So therefore, first arrange the 6 consonants. So this can be done in 6 factorial divided by the remaining 3 factorial into 2 factorial. That's it. So no 2 vowels are together means just arrange the 6 consonants. 6 consonants can be arranged in 6 factorial ways divided by 3 factorial into 2 factorial will give no 2 vowels are together. That's it. This is how we are going to solve this problem, right? Now, move on to the next problem. A similar type as that of the previous one. In how many ways the letters of the word accountant be arranged? In how many of them vowels are always together? So, first find out the total arrangement of the letters of the word accountant. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total letters are 10 letters are there. In which how many A's are there? 1 to 2 A. And C, how many C? 1, 2, 2 C. C is 2. Then 1 O. How many N? 1, 2. N's are 2. And T, how many T? 2 T's. 2 T's are there. Then remaining O1, U1. So totally 8 plus 2. 1 O, 1 U. So 2 plus 2 plus 2 plus 2, 8 plus 1, 8, 10, 9 plus 1, 10. So 10 letters are there. Now write down the total permutation with the letters of the word. So therefore the total permutation is equal to 10 factorial, 10 divided by 2 factorial into 2 factorial into 2 factorial into 2 factorial into 1 factorial. So this is the total permutations from the words, from the letters of the word accountant. Now what is the condition given? How many of them vowels are always together? Vowels are always together. Find out how many vowels and consonants first. A, E, I, A, E is not there. A, E, I is not there. O, U. 3 vowels. A, E is not there, I is not there, A, E, I, O, U is there. Only 3 vowels are there, right? Now, consider these 3 vowels as one unit. So, therefore, the permutation with the vowels, the required permutations with the vowels is equal to 4 factorial divided by 2 factorial, right? Now, the vowels and the remaining letters can be arranged, vowels and the remaining letters can be arranged in, so there are remaining 7 letters, so 7 factorial divided by 2 factorial into 2 factorial into 2 factorial. Now, just multiply these two will give the required permutation, that's it. So, therefore, the total number of A's is equal to, total permutation is equal to 7 factorial divided by 2 factorial into 2 factorial into 2 factorial into 4 factorial divided by 2 factorial. If you simplify this, you are going to get the answer as 7560. This is the required permutation, that's it, 7560. Okay, now move on to the next problem. Hope you follow. So these are few problems based on a word building and the letters building, where the repetition being allowed and repetitions being not allowed. So mainly we have concentrated on the letters which involves vowels and the consonants. So these are few problems based on type 8 and type 9. So that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.